This is video B for 8th grade 1-2 lesson. Okay, and in this lesson, this is your I can statement. You want to be able to convert from scientific notation now back into standard form. Remember, in the last video, we went from standard form into scientific notation. And so I'm just going to do two example problems with you in this video. It's going to be a little shorter than normal. But if I have a problem like 5.3 times 10 to the 6th power, how would I take this number that's written in scientific notation and turn it into a number that's in standard form? That's really the question. There's not a whole lot of vocabulary for this lesson. Just keep in mind that I want you to be copying down the example problems. So this is example 1. So this is just a multiplication problem. So you don't have to write it out like this every time, but I just want to show you what's going on here. You're multiplying 1, 2, 3, 4, 5, 6. You're multiplying 5.3 by a million. And I don't know if you knew what happened when you multiply a number like 5.3, let's say you're only multiplying it by 10. What happens is the decimal point moves to the right, one place, and you get 53. And you've known that because way back, from, I don't know, 4th grade, you knew that 2 times 10 is 20, right? Well, notice the only difference between 2 and 20 is one decimal point spot. Move the decimal point over to the right one place, and you end up with 20. So why do I say all that? Well, because I want you to understand why what I'm about to say works. When you multiply a number like this, 5.3, by a power of 10 with a positive exponent, the number is going to get bigger. So in other words, when I say the number is going to get bigger is whatever you write right here, where I just wrote the question mark, that number is going to become larger than the 5.3. And here's a vocabulary word for you. 5.3 in this case is called the multiplier. And I'll refer to that now in scientific notation. I'll say, okay, the multiplier. Why do we call it the multiplier? Because it's the number being multiplied by a power of 10. So it's really easy. First thing you do is you write down the number you start with, 5.3. I'll erase the question mark here. You look at your power of 10 and ask, am I making this number larger or smaller? Well, I'm making it larger because it's a positive exponent. Therefore, I must have to move it to the right 6 times. 1, 2, 3, 4, 5, 6. I trace it out with my pencil, then I rewrite the number. 1, 2, 3, 4, 5. I count the zeros. 2, 3, 4, 5. Then I added commas at the end. So 5.3 times 10 to the 6th power is the same thing as 5,300,000. So what was the first step I did? I first look and see, am I making my multiplier larger or smaller? Well, I'm making it larger, so then I have to move my decimal point to the right. In the second example, we're going to talk about making the multiplier smaller. So if I had 4.3 times 10 to the negative 4th power, remember that 10 to the negative 4th power is 1 over 10 to the 4th, or 1 over 10,000. And that's a really small number. And so I'm multiplying 4.3 by a really small number. Therefore, whatever this number is written in standard form, it's got to be much smaller than my multiplier, because I'm multiplying it by a power of 10 with a negative exponent. So I do this much the same way. I first write down my number, and I move my decimal point to the left now to make the number smaller. 1, 2, 3, 4 places, because it's a negative 4. And then I rewrite the number so it's not so sloppy. Whoops. Sorry, my pen's doing weird things. That's why things are coming out kind of weird. I apologize. Anyways, this number right here, 4.3 times 10 to the negative 4th power, actually means tens, hundreds, thousands, 10,000s, 100,000s, 4,300 thousandths, which is a really small number. And we would expect that because we multiplied 4.3 by a number that's going to make 4.3 smaller. Anyways, try this and see if you can't convert numbers in numbers in scientific notation to standard form. So go the opposite. Good luck to you.